What is 3D printing? 3D printing, also known as additive manufacturing, is a process by which physical objects are created by depositing materials in layers based on a digital model. Types of 3D printers. Stereolithography. Stereolithography falls under a category of 3D printing known as resin 3D printing, also known as VAT photopolymerization. These machines are all built around the same principle, using a light source like a laser or projector to cure liquid resin into hardened plastic. The main physical differentiation lies in the arrangement of the core components, such as the light source, the build platform, and the resin tank. Selective laser sintering. This is a 3D printing process that uses a high-power laser to sinter small particles of polymer powder into a solid structure based on a 3D model. SLS 3D printing has been popular amongst engineers and manufacturers for decades. It costs less to produce parts, which also allows for trial and error, as you can print more at a low cost, and the more we move into the 4IR, the more accessible the technology gets, as it only used to be available to high-end manufacturers as the technology wasn't cheap. Fused deposition modeling, FDM. FDM printers use two kinds of materials: a modeling material, which constitutes the finished object, and a support material, which acts as a scaffolding to support the object as it's being printed. FDM printers use a thermoplastic filament which is heated to its melting point and then extruded layer by layer to create a three-dimensional object. Majority of at-home 3D printers are FDM printers, as it costs less to buy. Digital light process, or DLP. The digital light projector is the light source of a DLP 3D printer. The DMD, digital micromirror device, is a component which is made of thousands of micromirrors used for navigating the light beam projected by the digital light projector. DLP, digital light processing, is a similar process to stereolithography from the perspective that it concerns a 3D printing process that works with photopolymers. The major difference, however, is the light source used to cure the resin. Multi-jet fusion, MJF. Multi-jet fusion is an industrial 3D printing process that produces functional nylon prototypes and end-use production parts in as fast as one day. Final parts exhibit quality surface finishes, fine feature resolution, and more consistent mechanical properties when compared to processes like selective laser sintering. MJF printers offer fast build times. Polyjet. A polyjet 3D printer, also known as material jetting or MJ printer, works in a similar manner to traditional inkjet printing, but instead of jetting ink onto paper, a printhead jets liquid photopolymers onto a build tray, where each droplet cures in a flash of UV light. It's one of the fastest and most accurate 3D printing technologies currently available. Electron beam melting, or EBM. There are two different types of EBM printing: metal powder-based systems and metal wire-based systems. Metal powder-based systems 3D printing is a technology in which a powdered metal is melted by a high-energy beam of electrons. An electron beam produces a stream of electrons that is guided by a magnetic field, melting layer upon layer of powdered metal to create an object matching the precise specifications defined by a CAD model. A metal wire-based 3D printer's approach is to use an electron beam to melt welding wire onto a surface to build up a part. This is similar to the common 3D printing process of fused deposition modeling, but with metal rather than plastics. With this process, an electron beam gun provides the energy source used for melting metallic feedstock, which is typically wire. The electron beam is a highly efficient power source that can be both precisely focused and deflected using electromagnetic coils at rates well into thousands of hertz. We will be using a FDM 3D printer. The accessories we're going to use are filament cartridge, cartridge locker, power cord, software CD, bed tape times 3 pieces. The bed tape is reusable and it can be replaced when it's worn. USB cable. Maintenance tools used are scraper, copper brush, cleaning brush, feeding path cleaning wire times 5. Step 1. Power on the printer. Step 1.1. Installation and removal of filament, calibration of the printing bed, and printing settings include change cart, home axis, Z offset or Z offset, jog mode, calibrate, build sample, and clean nozzle. Step 2. Loading and unloading filament. Remove the filament stopper tape and load the filament. Place the cartridge into the filament slot. Use the cartridge locker to secure the filament. Insert the filament into the filament hole and make sure that it's in all the way. Go to Utilities, Change Cart, Load Filament. Click Yes. In the next menu, you can customize the temperature of the nozzle, the bed, and unload. Step 3. Manually adjust the movement of X, Y, and Z axis for printer maintenance. How to move the extruder. Adjust the distance. Use up and down buttons to select the moving distance. Then select minus based on the desired distance and press the to the left button, or select plus and press to the right button to adjust the moving distance. Step 4. Calibrate the machine. Use the function to adjust the print bed and make adjustments based on the reference value. The printing quality will be affected by the levelness of the print bed. If you want to confirm the levelness of the print bed, turn on the function to measure and check recommended adjustment. Step 5. Software. Create a 3D model of what you want to print. Some 3D printers come with software that enables you to create or scan a design, or you can use a third-party CAD software. Step number 6. Printing. Open the printer and stick the tape on the print bed. Export your design to the printer's software in a 3D file format that is supported by your printer. Connect your 3D printer to your computer. Now it's time to print. Let the machine heat up and then the printing process will begin.